Hello and welcome to another John Brooks educational webinar. My name is Anita Gupta. I'm the divisional manager for filtration team here at John Brooks Company. Along with me, I have my co-presenter, Sean Marvin, who is our technical sales representative for filtration division, and he's located in Edmonton, Alberta. He has 20 plus years of experience in pumps and filtration. I also have a panelist with me, Niccolo Floresca, who is our inside technical sales supervisor, and he will be helping us out with the question and answer at the end. Audio and video will be turned off for all attendees during this presentation, and panelist and presenter will also turn off their videos. Please use Q&A function at the bottom of the screen to put any questions you may have. And last but not the least, if you need a certificate of completion, please let us know and we'll be more than happy to send it to you. Plus, a YouTube link will be sent to all the attendees, for you to listen to it after. And with this, I give to my co-presenter, Sean Marvin.
Hello, everybody. Thank you for joining us, and good morning, good afternoon. So John Brooks, just a quick intro, and then we'll get into the main purpose of our presentation here. Founded in 1938, so we're 82 years old. We are 200 plus employees across Canada. We're a privately owned Canadian company, and John Brooks has a lot of products. So we have a pump division, a filtration division, spray nozzles, custom skid packages, specialized valves. We get into air dryers, heat exchangers, pressure vessels. We have a ASME code shop. That's a quick overview of John Brooks. For today's agenda, we want to cover a few different topics. For those of that you attended our webinar 3, we covered in the self-cleaning more on the mechanical side. So this presentation, we're going to get into back-washable filters and the process for these back-washable media. We're going to talk about the different technologies for backwashing and try to give you an overview of things you need to know about these types of systems. And then we're going to talk about a quick overview of questions that you should ask yourselves, as well as questions when you look at applications. You should be talking to the manufacturers. All right, so in the backwashing world, some of the medias that we're going to be talking about is metal screen. We'll have stacked disc, microfibers, rotating discs, sand, your multimedia, that could be carbon as well, and then automatic cake. Again, in most of these products we're going to be talking, it's going to be more water-like, low viscosity. So essentially, dirty liquid-like fluids.
Right, so before we get into understanding various technologies of back-washable filter, let's understand what the process is. So this is a filtration system. So there's a filtration step, then there's a cleaning step, which is backwashing step, and then there's removing a solid. Filtration step is basically collecting of solids inside the filter, on the filter media. It could be on inside or outside. So that's filtration, which is capturing the solids. Cleaning part is when a pressure drop increases or is a preset time that will trigger a backwash cycle. What is a backwash cycle? Basically is flowing the clean liquid in the opposite direction to the filter media, right? And this could be timer based or pressure drop as an override, right? It could be done internal backwash by using the same clean liquid, or we can use an external source of clean water or some other liquid. Most important to understand in any good cleaning to happen in a backwash liquid is that either we need to have enough inlet pressure, that is for internal backwash, or if we don't have an internal backwash system, then we can add backwash assist pump or external backwash system, or we can add air assist, right? And the last step is to removing these solids from the filter body. That the purge line, ideally it should be to the atmosphere. If not, if it's a pressurized one, the pressure should be lower than the inlet pressure. Sean,
right.
You want to talk about the screens?
I do. So some of these different technologies that we will be talking about, we'll have a difference between surface filtration and depth filtration. As we go through the different technologies, we'll address this. Surface, generally is a thin layer of media, but in some of these applications, it will be what we would call surface, but it will act like a depth because we'll start building up a bit of a cake, right? And then we'll have depth. So again, we'll cover these when we get into the technology. So for the types of media, fabric will give us a range of somewhere between 1 and 100 micron. Then we'll have wire mesh between 2 and 140 micron. Slotted wedge wire, which will be very common in some of these applications, 25 to 150 micron. Stacked discs, 5 to 300 micron, that would be a good example of depth media. And then multimedia filters, kind of that 1 to 80 micron. And again, that would be another example of probably more in that depth style filtration. To start off here, we're going to talk about an intake self-cleaning screen. So I would refer to this more as probably your stage 1 filtration. So we have a screen, and these screens are, where are they typically used? We're going to put them in a river, a lake, a pond, maybe a tailing pond. And, this is where we're going to pull our water into our facility. So at this point, when we think about what do we want the screen to do, we're looking to remove, what's in this water. So sticks, leaves, weeds, rocks, all kinds of, whatever kind of debris there is. So with this, we have a water pressure driven self-cleaning screen. So again, we are going to be pulling water in through the screen, but while we're pulling water in, we are going to be continuously cleaning our screen. So it's a water pressure driven system. We have backwater flow of somewhere between 10 and 50 US GPMs. So this backwash water pressure somewhere between 55 and 100 psi. So when we look at this nozzle assembly, it does a couple of things for us. One, it's going to blow and continually keep our media clean and blow the debris away from the screen. It's also the angle of these nozzles. It's going to allow this rotating arm to rotate continuously, somewhere in that 15 to 20 RPM range. So it's just going to rotate and clean the screen, and we're going to keep the debris from plugging it up. There's an example, in the screen material media, we'll have a couple of different options, typically stainless steel, but we will have some, we'll have some options.
Yeah. Thank you, Sean. And also, you mentioned that these screens can be duplexed, manifolded to get, cover the more flow rate. Just to add to, where we need fish-friendly screens, if the water has fishes and we don't want to bother them, these screens have, certification for fish-friendly.
I'm sorry, I forgot to add there, our water pressure-driven system can be a slipstream off of discharge, or we could have an assist pump where we could have an external source of water if we didn't have enough water flow or pressure to provide our flushing.
Absolutely. Yeah. Thank you, Sean.
The next one we're going to cover is a back-washable screen filter. So here we're talking about a single body, so it's a pressurized vessel, and we're going to have a single screen. So we're going to have dirty fluid coming in, our inlet with our dirty fluid coming in. We are going to flow through our screen, which could be wedge wire, perforated, or mesh. We're going to flow through it inside out, and then we'll have our clean go out the outlet. When a backwash cycle is triggered, typically through differential, we will open up, the purge will open up, and it will be tied to a timer-based system or a pressure differential type system. And the difference in pressure between the outlet, which is also our clean fluid, and our purge creates, we have a rotating arm assembly, which kind of creates like a vacuum. So this rotating arm moves around in a 360 rotation and acts like a vacuum, and it cleans the ID of the screen for our backwash cycle, and then it just purges out the purge or the outlet waste stream. Now, some of these designs, you know, again, this backwash arm assembly, it's very close to the ID of the screen, but it's not touching it. So it's a very tight tolerance, and it rotates around. You can actually, there's some designs where you can have a brush that mounts on there, and it would, you know, go around the ID of the screen and brush against the ID of the screen to help clean it for that backwash cycle. That's about, yeah.
Yeah, thank you, Sean. Continuing with the single body, single screen here. A similar concept with this one. We have a vertical unit or a horizontal unit, right? But it's the single screen in there. There could be another pre-screen. Now, some of these designs, they have a pre-filter in there that is used to take out, you know, large debris, mainly to prevent the plugging of these cleaning nozzles or very, very fine screens. But the same principle, as Sean has mentioned before, at a certain delta P or a timer based, a cleaning cycle will start, right? And during the cleaning cycle, a portion of the clean water will go back. Of course, this motor will turn, that will turn these scanner assemblies or backwash arm assembly. As a result, the clean water is thrown out of these nozzles, and that cleans from inside out the screen because the filtration is happening from outside in. In this particular example, these nozzles have bristles there. These bristles are basically, they're not touching the screens. They are there to protect these nozzles from catching heavy debris. So same principle, single body, single screen. Instead of having one big hollow arm, it has an arm with number of cleaning nozzles. Continuing with that, single body, single screen. So this is your body of the filter or strainer, and it has a filter element. How to get a good clean, right? If you remember our physics class, Bernoulli's principle, you know, when velocity increases, pressure increases. So we use that to create a low pressure area in between the screen. So this is your screen, this dotted line, right? And that's the filter body. What we create a high velocity area. So this yellow arrow is creating a high velocity. And how we create that? By moving a disc up and down. When you bring this disc down, it creates that high velocity in it. That's why, you know, the flow moves, high velocity mean low pressure zone. Outside this red arrow, we have a high pressure zone, and inside is a low pressure zone. It will automatically, the water will move from the high pressure to low pressure zone, and a cleaning will happen. So if you look at now, we're on the left-hand side. In the filtration phase, our dirty liquid is coming from the bottom, comes up, and the clean one comes out. And when the delta P increases or a preset timer, this disc is actuated, it goes down, right? And it creates that high velocity and a low pressure zone, and backwash starts. Now, what the couple of advantage with this design is, even if we have a low inlet pressure or we have a low, not enough backwash pressure, this unit will still operate and able to clean. What I have seen, and also some manufacturers have started adding brush on this disc just to add more into cleaning. So something to consider that these type of units exist. That takes us to another style of back-washable cleaning system, which is also has a big, large one body and one large screen assembly, if I could so. I won't call it a screen. It's a screen assembly because basically it's a drum, and which drum is rotated, continuously rotating by using this motor. And this drum is studded with multiple filter media, these little baskets, right? So this drum is continuously rotating, and filtration is happening from outside the drum to inside. Now, as you can see, this is a motor and it has to rotate this big drum. Obviously, this is going to use a little bit higher horsepower than the unit that Sean was talking about, where the motor has to rotate a single arm. Sean, what kind of horsepower was in that previous unit? You remember?
On that one there, it's only going like 5-10 RPM, so it's only a quarter to a 2 horsepower motor.
Okay, yeah, good. I would imagine in this, we don't know exactly, this will be a much higher horsepower. So the process in this one is from outside, the clean liquid, the blue one, it goes in, and the same principle, the pressure drop increases or at a preset timer, the backwash cycle will start, and the backwash, number 9 is there that you have the backwash liquid to go in, your inlet, outlet, and it cleans, the whole assembly. This drum is rotating the whole time. I think what I see a big advantage of this design is, it's not a big, large screen. There are a number of tiny screens there, and if one get damaged, you don't have to replace the whole thing. But at the other hand, it's a very large motor, very large unit, and it could be pretty good for, depending on the application that we're working with. Now, that takes us to, we're looking at the inlet and outlet, and I think I want Sean to a little bit of touch on sizing of back-washable screen.
Yeah, a lot of inquiries that we see, people refer to them as, the line size. So we've got 6-inch, 150-pound, line size, and that's, yes, we need to know that, and that's only part of the equation for sizing a unit. There are many other factors when we get into, a back-washable type, filtration equipment. So yes, we need to look at it. Velocity is a big thing. And it's similar to the pump world where we're playing in that 6 to 10 feet per second. Filtration, we actually like it on the slower side. It's better for filtration and the life of filtration. So we would prefer to see it in that 6 to 8, but we play in that 6 to 10 range, for sizing it. The other thing, a big consideration is the micron size that the level of filtration that your application is calling for. The tighter the media, it reduces flow rate, and the nature of our debris and the amount of solids, right? So there's many factors involved in this. Hey, Anita?
Right, Sean. Yeah. So I think we're going to go more into detail on nature of debris and all that when we talk about what question to ask. In
Yes.
addition to the pipe velocity, it's really important that we speak with the filter expert so that he or she can also look at there's an optimal screen velocity, right? And then we're not compromising with the screen porosity. The flow rate per unit of area, it needs to be kept low depending on what micron rating and how much filter area we're using in there. Now that takes us to, the idea is we want to have as much as filter area as possible. How do we do that? If we're working with the unit that has a single screen in that filter body, right? It's not possible. However, you can have a design where in one body, you could have multiple filter elements, number of filter elements in there. It kind of look like you have a multi-cartridge vessels, right? Each element is, it's a complete filter in itself. In this particular example, the filtration is happening from inside out. The dirt goes inside the filter element, and during backwash phase, the clean fluid is sent back. So the dirt gets collected inside, and during the backwash, it pushes back, right?
So Anita,
sorry, yes, Sean?
In a backwash cycle, would we have any flow interruption?
Yes, no, good point. This particular style, there is no flow interruption. So for example, if we decide that based on the flow rate, we need 10 filter elements, we're actually going to put 11 or 12 because it backwashes one at a time. And there is at the bottom, there's a multi-port valve that sits underneath each tubes and clean it. Now, since we're looking at it, we might be wondering why the shape is like that. There are filters out there that have the straight shape, not necessarily conical shape. This particular design on purpose, manufacturer decided to make it a conical shape to get good clean and not end up with dead zone in that area. So they're sometimes referred as candle filter or multiple filter screen filters, right? Right.
All right, on this equipment here, what we're going to talk about is, so this again is multi-body with a common inlet, outlet, and purge header. So, and we're also going to touch on, we can have an internal cleaning system, an internal backwashing system and an external backwashing system. So this is, more what we call tubular. So each of these tubulars, inside there is an element, and I'm going to touch on those elements in a couple of slides. But if you look at the flow pattern, we are flowing, inlet is our common inlet is the bottom. We flow outside in through our media, and then we flow through a common outlet.
Oh, sorry.
So when we do a backwash cycle, right, this is showing an external backwash cycle. We flow inside out to, clean our media, and then out through a common, purge or waste line. Then if we go to the tubular unit on the left, I refer to these more as an octopus design. These will have 8 of these tubes, and inside there will be elements. And again, similar, we flow from the bottom common inlet. From the bottom, we are flowing outside in on our filter media, and then out our common outlet header. Now, this being an internal backwash cycle, we take our clean outlet fluid that's already been filtered, and we use that for our backwash. And that backwash pressure is the difference between our clean outlet pressure and our purge, which is atmospheric. So good rule of thumb is we want a 2-to-1 ratio for pressure for getting a good backwash cleaning. Now that picture on the bottom left there, that's showing, units run in parallel, but it's also showing it would have an external backwash cleaning to it. And I think Anita's going to talk a little bit more about that on the next slide.
Yeah, no, Sean, just a quick question. On these one, the multi-station unit, this can also be internal backwash, isn't it?
Internal backwash, yes. Sorry,
Yeah.
and on these ones,
yeah. These are also can be both internal backwash and external backwash, depending on what the application calls for. But this style of unit is always internal backwash.
Correct.
Unless it's for this, right? And the one that Sean's talking about on the left is that we use more for non-water liquid, where we can't use the same water for backwash, more in oil sand application, more for the, I would say, feedstock filtration. That's a lot more into it. Maybe we could have another session for that.
Yes. Now here, we just wanted to show you the flow path is outside in, dirty fluid to clean fluid. And then when we do our backwash, we are flowing inside to out, and then it would go out into our purge chamber. Now, the pictures, yeah, that's the middle picture there. We talked about those elements. What's inside there is why I kind of wanted to push it to this slide is we have a few different options for the media. So, that design in there, we could have a single element. We could have a tri-cluster, which would be that middle picture. We could have a 5 cluster. We could have a 7 cluster, which is that bottom picture. And then they even make a 15 cluster. And these are going to be like that bodies is 6 inch in diameter by 36 inches long. So really what we're getting at here is it's all about surface area, right? And then we also have these are called diffusers, and they actually fit inside the ID of our media, and they're to help with the backwash, to get good backwash to to make sure we clean our media really well when we do that backwash cycle. They're called diffusers for optimizing cleaning.
Yeah. Thank you, Sean. Now this one is now let's touch quickly on this. These type of filter can also be used for non-water like liquid. Like for example, amine. right? And the critical step in amine filtration is, of course, how would you use a back-washable filters? You're not going to backwash with amine. So these are different filter bodies, right? Filled with those tubes, those multiple tubes filter. It could be maybe 15 cluster unit, right? And I'm going to quickly show you what is unique about the backwashing step of this. The backwashing is a multi-step process. The very first step is we actually do nitrogen purge of this media, right? And after the nitrogen purge, then we backwash with hydro boost, kind of backwash with water. And then we again nitrogen purge. We inject nitrogen again to eliminate any extra water before it puts back into the process. Now the same thing, one body cleans at a time when all the rest of the bodies are working. Again, there is a lot more detail into it. If anybody is interested, we'll be more than happy to talk about it. Okay.
This would be ideal for H2S.
Yes, yeah, avoid changing a lot of cartridges.
Yeah. All right, so now we're going to get into, again, this is non-metallic. So, you know, here again, we're talking about a single body using a common inlet, outlet, and purge header system. So it gives us a smaller footprint, allows us to, you know, have a lot more of these bodies to it. So this is, you know, a disc filter, and they stack to become what I would call a cartridge. And this is a good example of depth filtration. They're color coded for the different micron sizes. You know, again, we flow outside in, and when we do a backwash, we flow inside out. And that backwash cycle, the disc, I don't know if I want to say it's spring loaded, but when we do a backwash cycle, it opens up and all of these discs separate, so you get a good cleaning during the backwash cycle. And yeah, they're pretty slick. And I think the next picture, Anita, has a unique application we worked on here a while ago.
Yeah, Sean mentioned that these are non-metallic, good backwash, and almost like a combination of surface and depth filters. This application, I just want to quickly show it there because we ran into an application where it was water, but water had dissolved salts in it. So there was some chloride content in it. So we could use the metallic filter, but we needed some fine filtration. So you could see this was a multiple station unit, and the water had algae and organic in it. Just because this is not a screen, there was no chance of fibers or algae stapling on the metal screen, and the discs were separating during backwash. It was able to give a very good clean. But also at this time, there is another unit down there. What we're using this one for air assist. So this part was filled with clean water all the time, and the air is injected in it, and it helps in more cleaning.
Right. Disc filters are good for stringy material, fibrous material.
Yeah,
too.
Definitely. Stringy, softer material. Yeah. Now, continuing with non-metallic filters, you know, I just wanted to show options out there for us when we're, you know, serving our customers. This is an example of a microfiber film. The element is made out of microfiber. So what there we see here, number one, it's a cartridge assembly, and this cartridge assembly is made out of all these fabric made out of fibers. We can call them the cassettes, right? And these cassettes are all joined with the header on a common header. And the principle is still same. Filtration happens and the pressure drop increases. When the pressure drop increases, then the backwash starts. These one, you can see the inlet port, outlet, backwash, and drain port. Just to quickly to go over the process on this one. This unit, it stops when it needs to clean, right? And it almost takes about 10 minutes for the backwash. The backwash happens by using this pump that supplies the clean water to this part that's it's supplied with the nozzles, and these nozzles will spray clean water on this cartridge assembly, and this cartridge assembly will also rotate so that all parts of these will be cleaned, right? They can actually filter pretty fine. They can even go down to 2 micron. For our tertiary filtration application, we could take water directly from clarifier. So it has its place, but just to know this technology exists. Now, moving on from fabric media to depth media, multimedia filters, right? It has its place. Some people, although they don't like it, but they're depending on the application, we need to use it. Now, in this particular presentation, we're talking about pressurized back-washable media filters. There are also gravity feed, which are very common in municipal applications, where the gravity sand filters. So that's not what we're discussing here. So the common application for pressurized media filters are, for suspended solids reduction, or we could have dissolved metal reductions like manganese and iron from well water, groundwater, depending on what media we're using, activated carbon, softener. Again, that's a separate whole new topic. It could take definitely more than an hour. We can go into more detail on that. But what I want to touch on is for a little bit, not a whole detail, a little bit about the sizing of these units. It's very critical when you're sizing it. We watch for our service flow rate and backwash flow rate. If you notice that the service flow rate is a lot lower than the backwash flow rate, right? Because you are needed to backwash a big depth of filter media, right? And, there are experts out there, and we could also help our clients with that. There are different medias available depending on what the application is. On the left, there's an example of multimedia filters. So most of this application will be to remove suspended solid. There will be a layer of garnet, layer of sand, gravel at the bottom as a support layer. Talking about the support layer, there's under drain distribution, and at the top is also distribution. In most cases, the filtration happens from top to bottom. So dirty water comes in, media gets dirty, and at a pressure drop, the backwash starts. Mostly the backwash is there is an external source of either clean water, or if it's a multi-station unit, one of the station can be used for backwashes and others are still filtering. Okay? And then, there is other design factors we need to take into account, how much space needs to be there and all that. That's a more detail that we can go into some other time. And I would like Sean to touch a little bit on the paper filter type here.
Right. Yeah. So again, this is gravity fed. This is what we call a self-indexing paper media filter. So, you buy these rolls of this paper roll. There's different medias available to us, right? Again, I look at this as more on the coarse side. So you'll order like fine, medium, coarse. But essentially, you have a flood box, and the flood box is where you dump your dirty fluid, and the paper's on the bottom of it, and you've got wheels that kind of contain this flood box, and then you have a probe. And the probe is is sensing the water level. So you dump your dirty water in there, and as your water level increases, we're filtering the media, and it will start to build up a cake. And then as that cake builds up and you get the finer solids, eventually it's going to plug off the media, and then our water level is going to rise. The probe's going to sense this, and it's then going to advance it'll tell our wheels to advance the conveyor system, and we'll get a new piece of media, and the whole process starts over. The old media, as it's a continuous roll, just dumps into a waste container. And it's that simple, guys. These can vary in sizes.
Thank you, Sean. And I believe these are very common in those coolant filtration applications and all that, right, Sean?
Yeah, coolant, again, large particles, right?
Right.
Yeah.
Now, talking about the paper media, or what Sean has mentioned, the flood box there, gravity, rotating disc media is, I would say, a self-cleaning version of this, where we're using the paper maybe paper is not the right word, the cloth media, and on the sides of a disc, there are multiple discs submerged into a flood box. Multiple discs are in there, and these discs drum, it rotates, right? And this media is a woven media. It's cleanable media, cleanable by backwashing it. So when this is submerged in the water, so you can see whatever part is, you have the dirty liquid coming in, and the bottom, when it's get dirty, just like happens in the previous one there, probes tells us that, okay, it's dirty. So that's a signal to tells this drum to rotate. Now the clean part of that media disc will be there exposed, and whatever's the dirty part will come up, and these backwash nozzles will be supplied with the clean water that will be sprayed on this media cloth, and it will clean it. And the backwash nozzles headers also rotate. And there are a couple of different versions of that. Different manufacturers have modified it slightly, but that is the basic concept. And with this, could filter pretty fine. Very common for tertiary filtration applications. You could take directly from a clarifier or coagulated water. It's very common to use enhanced coagulation before that, and then this used for the finer filter, right? It is still strictly to reduce the turbidity, reduce suspended solid. It's not removing our microbes or anything. It's removing strictly the particles. Before we open our question and answer, I wanted to quickly touch on, this is not really a back-washable where you're using the backwash water, but this is also an automated type of system where you are creating a filter media right there. We have seen that as leaf filters or a filter press type of thing, or candle filters. And the steps in this one is, you fill your filtrate into a vessel, and then we deposit the cake on filter candles or leaves or filter press or the disc, and then filtration step happens. And of course, then the solid removal by blowback, not backwash, blowback, and solid discharge. And for blowback process, air or nitrogen is very commonly used. It's basically you're shaking off those particles of the filter media. All those solids will come off, all the media will also come off, and then the process start again to start building the cake, start building the media, right? So this shows that's the same thing again. But what I want to touch on this one is, there are some right applications for this and some not very right applications, right? Yes, it does give finer filtration. I have seen it sometime, this type of technology used in amine filtration, right? But then you get into building the cake and all that. And Sean was telling me that he has seen at a customer, Sean, was a pretty messy step.
Yeah, that was more, I look at those as probably more batch processes, but then after they did the batch process, the maintenance department comes in, and it's like an 8-hour job to clean it ready for the next batch.
I remember they were saying that, it's too many steps. They have to mix this filtrate into a tank, and then they have to pump the filtrate into the coat the leaves with this, right?
That's the easy part.
That's
the easy part. The hard part is cleaning it up afterwards.
Yeah, you have definitely worked with a lot of operators. You understand their pain, Sean. Yeah. Also, just to add to that, there are some manufacturers who have come up with the pre-coated media pads. And sometimes, we have talked to the clients where they're using it. They can switch to pre-coated media tanks. Those media pads have DE, diatomaceous earth filter on it, kind of they have the zeta potential on them. Right, Sean? Those are depth filter sheets.
Yep, exactly.
Now, Sean, I think since you have worked a lot in the field with the customers, and you always tell them to, understand your needs first. Can you elaborate
Exactly.
on it?
Yeah. So, again, when I think about if I have a filter application, um, you know, we're solving a problem, right? So first we need to know why do we need this, and what's the problem we're addressing, and again, what are we trying to remove? There's obviously some sort of undesirable particle going on, or whatever. So it's getting a good understanding of that and why you need this. Then you want to look at this system, and how you want to run the system. Do you have people available? Do you want it to be, where is this location in relation to how it's going to be run, right? And then, we look at your cleaning cycle and frequency of that, right? Again, when you look at this application, one of the questions I always ask is, are we challenged with removing 1 pound an hour, 10 pounds an hour, 100 pounds an hour, 1,000 pounds an hour, right? That has a big impact on, having a good understanding. And then, there's some other basic questions that we need to know, right? Obviously flow rate and the nature of the fluid, our contaminant. What shape is it? Is it hard? Is it soft? Is it deformable? Is it fibrous, right? All those different things, right? How much of that is there? This is where I'm interested in your TSS, total suspended solids, or your particle size distribution, which is the range of micron sizes we're being challenged to work with, right? And then obviously, pressure, design and operating, temperature, right? We have different medias to use, and then potential hazards, right? In where this is used in your application, right? We need to address that. And then, specific codes, right? There's, the different codes we have to play in. And again, we, with our different manufacturers, we have all these options covered.
Right. Thank you, Sean. Now, in addition to, so that's the thing, Sean. I think you're saying that before we call a filter manufacturer, right? Those are the questions we need to ask ourselves, okay? Or customers should ask before calling a filter manufacturer. But the questions that we should be asking a filter manufacturer or suppliers when we get a quote or when you receive a proposal, ask the questions like, what type of particle removal efficiency your filter is giving me? I asked you for 150 micron removal. Are you removing 90% of 50 micron? You're removing 50%. So that's a question. If you don't ask, you won't know, right? And also what kind of pressure loss your filter is going to give. What is going to be the clean delta P? What is going to be a recommended change out delta P? We keep mentioning that it should be a preset delta P. What is it? 5 psi, 10 psi, 15 psi, what it is. So those are the questions we must ask. And does your filter needs a minimum feed pressure, right? Does your filter has a maximum solid loading, right? If I have, I don't know, 500 NTU, which could be equivalent to 1,000 parts per million, what's the limit? Most filters, back-washable filter has a maximum TSS limit of 200 parts per million. Sean, is that the right number?
Yeah, you see, 200, that's pretty, with the backwashing style, that's getting towards its upper limits, right?
Right,
when we get into higher, we have, might have to look at stage filtration to reduce it.
Right. And also, I think then we should ask the filter manufacturer, what type of cleaning mechanism using? Are you using that rotating arm style? Or you have those scanner nozzles? Are you using brush? Are you say that you're using Bernoulli's principle? Or is it a mechanically cleaning filter, right? And we all talk about we need a good backwash pressure, How much it is? What do I need? And that will depend on if the water has algae, sticky material. We may need higher backwash pressure than 15, 20 that is regularly asked for, right? If we don't have a good inlet pressure that we can also use at a backwash pressure, can I use a backwash assist pump, right? Can I supply external backwash water because I don't want to use amine or any other fluid to backwash it? Because we use very commonly these backwashable filter, especially the tubular one that Sean was showing in pulp and paper industry. For whitewater application, for sodium chlorate applications, very, very common. And there are a number of times we use external backwash instead of internal backwash. And what type of screen your filter offers, slotted, mesh, or how are you increasing surface area? Are you putting multiple elements in a single body, or are you maybe pleating your element to increase the surface area? Are your filter element conical or straight shape? How are you taking care of removing, not having that dead area? Are you using some kind of backwash diffuser to create that high velocity? Okay? What is the open area ratio of in your filter element? Right? You want more holes, you're paying for a filter. You're not paying for a dead filter plate. So there needs to be an open area, and there need to be a lot of surface area. Another thing that's commonly get thrown at, flux rate, more popular when we're sizing membrane filter. But flux rate is equally important in any sizing of filter. When we size the filters, we do not size the filter based on the line size or hydraulic velocity. We need to keep the flux rate low as possible. Lower the flux rate, better the filter, long it will last. It will reduce the cleaning frequency. And how we can reduce the flux rate? By packing more filter area in a single body. And also we should ask that, hey, my water is surface water, it might have organics. How's your filters going to handle that? What if my water has algae in it? Is your filters going to get plugged, or is it able to handle it? So these are all the good questions to, I would say, probe your supplier or manufacturers for this.
Anita, I'd like to add one more thing.
Yes.
One of the things that, questions that I've learned to ask is, do we have seasonal conditions? You got to think about look at the calendar, and during the summer months, you tend to have more algae or organic issues because of the temperature versus winter months. That's another thing I've learned is, let's look at the different seasons and because it's going to change our environment.
Definitely, yes, yeah. No, I know, when you go there, and so many times, and I've been in the shoes of a manufacturer and a supplier and a customer, right? Sometimes we end up talking to one manufacturer, and that manufacturer has interest in only talking about his or her filter, right? I think you want to talk to a company who can give you multiple tools, who can give you different type of technology and understand how these different technology works. At the end, I would say, what I would like to say, there are three things if we can get out of this presentation. I know there were a lot of material in it. Design or selection of any equipment, the very first step is understanding your own requirement, design conditions, limitations, where the fluid is coming from, how clean do we need? Do we actually need a self-cleaning filters? If we need it, why do we need it? How fine do we need it? So first step is to get ourselves educated, and also to get ourselves educated as a customer. What are the different technologies out there? You could, yes, there is information out on Google. We can all read it. But I will say that talk to people who have experience in using this technology and working with this technology. Because at the end, we don't want a filter system not just to meet the filter water quality or filter fluid quality. I mean, it should be robust enough. It shouldn't become a pain. We should select a filter system that is important to not become a maintenance headache, if I could say. Right? And at the end, I will say that please take time to read more into it, ask more questions, and consult some experienced individual and experienced company, and ask about the operating and maintenance information on that. Yeah. Sean, do you want to add anything to this?
No, and also keep in mind that some of this technologies we do have available to us to help you with these applications for what I call test and trial, pilot applications. We can bring some of this technology out there and try it in your environment.
Yes, definitely. I think that's it. That's a great idea, especially if, and every environment is different,
Yes.
right? Depending on sometimes we take the water intake from a river or pond, depending where we're taking it from. If I could just quickly bring in an application, yesterday, myself and my other coworker, Linan, I think we were listening, we were speaking to a client where the water was originally taken from the river, all good and nice. And then before it goes to the seal water, it actually going into a pond. And that is an open pond, and all the leaves and twigs and everything was falling in there. And on the top, algae is growing in that pond. And that water was sent into a 50 micron screen. You can imagine what would have happened. All right, so let's open our floor for questions. Nico, do we have any questions?
Yep. The first one is clean water loss when backwashing required the same for various units? So this is actually a good question because that's not something that we necessarily touched upon.
Yeah, you want me to answer this?
Yes.
Yes.
Good question. I think, yeah, we forgot to. The clean water loss for backwashing required is different for different unit. And that's the question I think I had it at the end, ask the manufacturer. So the one unit where Sean was showing with the scanner arm, it has about 5% loss for every clean. Now the question is, what is every clean? If the filter is not as correctly, your filter might clean every 15 minutes, or your filter might clean every 6 hours or 10 hours. But every clean, you could lose about 5% of water. And I've seen up to 10%.
Yeah, and that's going to vary from technology to technology, but also, it's what we're filtering. It's it's going to be tied to your TSS level and the micron rating, right? And that's something that's your dirty fluid kind of dictates that to us somewhat, right? And this is again when I talked about seasonal conditions and understanding what it is you're dealing with, right? So we can address it, because we really need to address it in the worst conditions possible.
Mm-hmm.
Right. No.
Another one of the questions actually relates to this one is you touched upon the air assist system. Would that in fact reduce the amount of backwash compared to the disc system without it?
Definitely. The air assist is used not in that disc stack filters. Air assist is very common in the media filtration. You have the air injection there. That's basically idea is to, I don't know if that's the right word, loosens the particles. So to make the particles loose, and that will come off. So air assist is very, very commonly used in membrane filtration, in disc filtration. Yes, thank you, Nico, for adding that. Yeah.
Mm-hmm. Another question is pertaining to the self-cleaning strainer that utilizes the Bernoulli's principle as part of its backwash procedure. So is this something that would be preferred over specific conditions?
Yes. So going back to what Bernoulli's principle is, when the velocity increases, pressure decreases, right? So anywhere if you have a filter and you want to use that as an internal backwash system, you don't want to bring an external supply of liquid. So to use this as an internal backwash system, you got to have a good pressure coming in so that you could use that pressure also for the backwash. But if you don't have that, Bernoulli's principle will create, the high velocity will create a low pressure zone. And as a result, you can also use it in a low pressure application where your inlet pressure is relatively lower. And if I might add there, if you think of it, all those scanners arm and rotating arms, what are they actually doing? Sean mentioned that it's a great idea to have that rotating arm all the time. Nico, what are we doing? We're actually creating we're creating higher velocity, right?
That's right.
And by creating higher velocity, we are creating the low pressure zone. And as a result, we're pulling the clean water from outside in.
Yes. So that just to add upon that more, because the primary discussion was for backwash filters, that's kind of the Achilles heel almost for backwash drainers in that you require a minimum pressure. But for the strainer that utilizes Bernoulli's principle, you can almost get away with a gravity feed system so long as you have enough head.
Right, right. Nico, I see a question here about the media filters. I know saying that you briefly touched on the service flow flux rate and the backwash flux rate, why the backwash flux rate is higher. It's a depth filter, and backwash flux rate is it's always 1.5 times of incoming flow rate or more. In any self-cleaning filter system, the bottom line I think we need to look at is the total overall recovery. So your screen backwashable filters, right? At any given time, you might be losing 5% in backwash. So your overall recovery is 95%. But your backwash flow rate is same as your incoming flow rate. But what happens in media filters, backwash happen, if it's sized correctly, a lot less often than what it happens in the screen filters, right? And then, but we need a much higher velocity, much higher flow rate to get that good clean. But at the end, I think what we should be looking at is what is our overall recovery at the end. How much water are we losing in the process of backwash or drain or other processes?
Thank you, Anita. A new question that came up is, can you transition from a rotating disc cleaning filter to another method?
I'm not quite clear what the person is asking here. Transition from rotation disc cleaning to another method.
Right. I think the question is concerning the what alternate kind of pieces of equipment may take place of that disc filter that I believe we were covering the last slide. I think that's
Okay.
disc.
Yes. I mean, I don't know. I mean, the reason somebody has installed a rotation disc cleaning, because I would think that somebody has dotted the I, crossed the T, and that must have been the best technology. If customer somehow believe that it's not the best technology and it's not working, there are multiple other technology we can take a look at it. But at the end, you know, not everything fits every application, so we need to. Like, why do they have the rotation disc cleaning filter to begin with? I think that's the first step to look at.
Right. You'd have to review the application.
Yeah.
So there's certainly more nuance to this one. And there's definitely other pieces of equipment that may be suitable for it. But if this is something that you're interested in, we'd be happy to get into it more for you. Okay, another question. Actually, the person that had prompted the question, in fact, had said that I have a customer that's utilizing a rotational disc, but the service costs are very high. So, yeah, there you go. That's then.
Okay, so I think we need to speak on the side then. This time may not be enough to do this. Yeah.
Yep. Okay, and then we're closing in on the 2 o'clock now. The last question that came up is for large flows, 600 cubes per hour and high turbidity over 200 NTU. What is the continuous system that you would recommend?
Oh my God. That's what I was getting. 600 cubic meter per hour. That's about 2,600 GPM, right? Isn't it?
That's a lot. Yep.
That's a lot.
I was going to ask what level of filtration?
High turbidity, 200 NTU is very, very high. One thing I think it's not going to be a single state system. There will be a multi-state system. And at the end, I think it depends, what is our end results? Yes, 600 cubic meter per hour, that's simple, not a big deal. I think I'm more concerned about here is incoming turbidity is very high. Now, let's say if you only need to remove particle larger than certain size, and most of the particles are smaller than that, and they will pass through the screen, you know, we don't have a concern. So I think there's a lot more to discuss in this application. And we have, how do I put, we have worked on a number of such applications in there.
Yeah, when I hear that 200 NTUs, I'm thinking it's very dirty, and I'm thinking we have fine particles in the water, which is, you know,
right, and the turbidity
challenging.
could be also coming from, turbidity is largely a function of suspended solid, but it could be, you know, high organic content can also sometimes gives a high turbidity reading, right? So I think more importantly, we would like to know more of the suspended solid. So it's not a straight answer. I think we can talk about this on the side.
Yeah, for sure. Yeah, great questions that were forwarded to everyone.
I think there are some more
So-
questions, but Nico, we can probably answer them after, right?
Yep, offline. Yep. So if you want to make the closing statements, I think we're good to go.
Right. No, thank you very much. And I think I'm going to say thank you. At the same time, I realized, Sean and I both realized that there was a lot of material in there, and maybe it felt like we were rushing. But at the message, we want to thank you for attending this. Please don't hesitate to contact us, and please let us know if you need a certificate of completion.
Yeah, thanks everybody. Like I say, like Anita said, probably each of those technologies we could have spent an hour on, but to try to give you an overview.
Yeah, well, last but not the least, next week, we have another webinar that will be presented by Zen and Glush on air filtration. Gas and air filtration. Zen will be presenting it. We'll be sending you a link for that, but please take some time to visit our website. You can sign up for our pump webinars, our filtration webinars, air webinars, and also you can listen to the recording. That's it, and thank you again, everybody, and have a good rest of the afternoon.